All right, let's dive into the fascinating and honestly pretty humbling world of AI reasoning. Today, we're going to look at a brand new challenge that is pushing even the smartest AI models on the planet to their absolute breaking point. So, here's the game plan. We'll start by looking at how AIs got so ridiculously good at math. Then, we'll talk about the weird problem that success creates. After that, we'll introduce a brutal new test, see how the world's best AIs completely struggled with it, and then wrap up by looking at what this all means for the future. Okay, so first things first, let's just take a second to appreciate how unbelievably good AI has gotten at solving math problems that, let's be real, would stump most of us. I mean, just look at this. We're seeing sheer dominance. On really hard tests, like the American Invitational Mathematics Examination, or AMI, the best models are scoring in the 90s. On other tests, they're getting near-perfect scores. And I want to be super clear, this is not your high school algebra homework. This is high-level competitive math. When you see scores like that, you have to ask the question, right? Is this it? Have we basically solved this? Is complex math reasoning just a checked box for AI? Well, it turns out that all of that success is actually creating a brand new headache for the very people trying to make AI even smarter. So let's jump into our next section and unpack how getting a perfect score can actually be a really bad thing if you're trying to measure real progress. And this brings us to this key idea called performance saturation. Think of it this way. If every single student in the country suddenly got a perfect score on the SATs, the test would be useless, right? You'd have no idea who the real geniuses are. You'd need a way harder test. And that's exactly what's been happening with AI math tests. They're just getting too easy. So, to solve this saturation problem, a group of researchers built a new, much tougher test, and they call it AMO-Bench. And this quote just perfectly captures their goal. They wanted to create a benchmark that's at the level of the International Mathematical Olympiad. We're talking the absolute peak of high school math, or maybe even harder. This is basically the intellectual Olympics. And building this thing was no joke. It was the super rigorous 4-stage process. They had human experts, a lot of them former Math Olympiad winners themselves, create totally new problems from scratch. Then, those problems were checked for quality, for originality, and finally, they were tested against the best AIs just to make sure they were actually difficult enough. So, what really makes AMO-Bench special comes down to 3 things. 1, every problem is brand new, so the AI can't just cheat by remembering an answer it saw online. 2, guaranteed extreme difficulty. And 3, it's a simple final answer format, which makes it super easy to grade and test a whole bunch of different AI models quickly. The final test has 50 problems that cover the whole range of advanced math. You can see here it's a really comprehensive mix, everything from number theory and geometry to functions and combinatorics. The whole shebang. All right, so now for the moment of truth. After building this absolute monster of a math test, how did the most powerful AIs in the world actually do? This is it. This is the score from the single best AI they tested, GPT-5. Just over 52%. I mean, just let that sink in for a second. So after cruising through the old tests with 90+% scores, the very best AI could barely pass this new one. And as you can see, it wasn't just a fluke. Other top models like Qwen 3 and DeepSeek also really struggled, not even hitting the 50% mark. To put that into perspective, this is a huge, almost shocking drop in performance. It just shows what a massive leap in difficulty this new benchmark is. The star student is suddenly struggling to pass the class. And it's not just that the AIs are getting the answers wrong, they have to think about them for way longer. This table shows the number of output tokens, which is kind of like the number of words the AI writes to solve the problem. It's a good measure of effort. For the old tests, it was about 6,500 tokens. For AMO-Bench, that number just skyrocketed to 37,000. That is nearly 6 times more work just to even try to find a solution. But here's the twist. This poor performance, it isn't actually a story about failure. In a weird way, it's a story about opportunity. And it's a really exciting one. Let me explain why. See, hidden inside these low scores, the data revealed a really promising and predictable pattern. Something researchers call a scaling trend. And here's the key insight. When the researchers gave the models more computer power, letting them think longer about each problem, their scores went up in a predictable, almost straight line. More thinking time literally equals better scores.
You can see it right here with GPT-5 jumping from a measly 25% all the way up to over 52%.
And this is the big takeaway. That predictable improvement tells researchers that we haven't hit a wall. It shows that future, even more powerful models will almost certainly get better and better at these insane problems. It gives them a clear path forward, a target to aim for. So, AMO-Bench hasn't just shown us where AI is weak, it's given us a much better ruler to measure progress. And that leaves us with this final, really exciting question for the future. Now that we have a proper test, how long is it going to be until an AI can finally earn its PhD in math?